So hi, I'm Filip, head of DevRel here at Flare, the talk before me was really nice. Pretty much said all the things I wanted to touch upon. So the main idea is, so you have the data, you have it on blockchain. This is an Oracle summit, so the first statement is pretty clear. So nothing lives in isolation. What does that mean? Well, you need some off-chain data. You need some data in addition to what you can only get by solidity statements or move statements and so on. And the thing is, how much do you value this data? And not just this, it's also how much will the attack cost. And as you're on blockchain, you've already made a huge decision, which is I wanted to do something on blockchain, which means that your awareness towards security, your awareness towards financial security is quite high. And that means that pretty much anything that's standing in the way of you getting the correct data or you getting the data that can be manipulated is at some point problematic. So the thing is that the security across the whole pipeline, not just the data acquisition, but also how you get the data to chain, who do you trust in the process, and what you do at the end with it, the blockchain computation, is at best a function of minimum of all the data, of all the security assumptions in the middle. So what that means that if one part of the chain breaks, you end up with an application that is doing exactly what you want. It's computing exactly the sorted value of something, multiplying it and doing a liquidation of whatever you need, but the data you're acting upon is wrong in the beginning. So what you need to do, both as an application developer and as an infrastructure developer, you need to make sure that you know what your data assumptions are, as we heard, you know what your security assumptions are, and you know the cost. And each part of the pipeline needs to be secured. Otherwise, well, which part are you going to attack if you're an attacker, where you're going to attack the easiest one to do? So accessing this and making sure that this is correct is a non-trivial task. And what we did, well, we practically built a whole new blockchain that is specifically focused on making sure that this data provisioning part has the same security assumption as the execution part. So what did we do? Well, we created a separate network that's not a layer 2, that's not a roll-up or something different, but we wanted to have our own validator set. We wanted to have a validator set with stake, and exactly this stake, the stake that is guaranteeing the execution of code, the stake that is guaranteeing the consensus layer, is also guaranteeing the consensus layer upon data. So that means that the data consensus, the consensus about what are we going to put on chain that can later be used in execution, follows the same security principles. It's a non-trivial thing. There's a bunch of things that you can easily do, and there's also a few things that are non-trivial to do and make a development environment a bit more problematic. So specifically, what did we do? We took the validator role and partitioned it so that each validator now also has to be a data provider. And that is not cheap. That means that most of the inflation of the network also has to provide for this data provisioning, which means that you have different security assumptions upon the network. What does that mean? That means that on the network, you are limited to data points, or you have to work with data points that can nicely be made as a consensus on top of the network. So for example, if we're talking about prices, you have to be careful which price you're considering. You have to be careful to properly define what a price is and how are you going to source it, and that means that you are in a way limited. For example, in our case, we can only slowly add prices, because if you want to secure it by the whole stake, it takes time for the whole validator stake to get access to these prices, to properly support them, and then be able to put them on chain. But this is for non-deterministic data. For deterministic data, when you want to extract some data points from a Web2 source, you again have to be careful. You have to construct this attestation. You have to construct the ability to get this data point in such a way that it's easy to create a consensus on top of it, so that you know how exactly you can slash on the validator level. So again, in that case, what you have to do, you have to present your data point, you have to present your data acquisition point in such a way that all the validators can access the same information, either via pre-processing, either via post-processing, creating a nice solidity adapter and interface at the end of it, and then also be able to properly give money back to the validators in such a way that this process is not unprofitable for them. What that means, if you want to access a bunch of different data points and all the validators have to check those data points, you need to make sure that access to those data points is not behind the paywall, or that access for those data points is behind the paywall, but you make the users of these data points at the end properly re-enumerate the validator so they can access those payloads. Because if you're under a paywall and you just create an additional API and say, okay, instead of Twitter's API, use my API that is sourcing Twitter, and I'm going to give you everyone an API keys for my specific server, well, at the end, you're pretty much just trusting, again, a single person. So those are a few problems that can, in a nice way, be encapsulated and secured, and then pushed to the validator level, as long as you make sure that the validators are properly enumerated and that the validators know how to participate in this and are able to do a slow rollout and are able to continuously update your data sources. So it's both about the definition and making sure that you don't overextend the validator set. And so what we were able to do at the end, what this powers, well, as long as you can trust something, as long as you can say, okay, we're going to do a specific deterministic attestation, you know what your trust assumptions are. So you can make a nice prediction market, but you know exactly what your data pipeline is, and you know where your greatest weakness lies. So as we've heard before, some employee of a Facebook can change the website and produce something different. What this actually means is that you have to educate your developers to be able to make certain assumptions and to be able to make certain specific data proofs and say, okay, so here's my data pipeline, and what we're going to do, we're going to say, we're going to focus, and we're going to finalize our bet or finalize our prediction market and exactly on what the Facebook says. This means that you have to upfront create a code sample, you have to upfront create a deterministic finalization, and know that this is your specific pain point that can be problematic. And furthermore, so you can do a bunch of other things, landing protocols for pricing data and so on, but it's all in this data pipeline. So what we're doing, you're slowly chipping away problematic security points. And that's it.